Rational expressions, when put into an equation, look pretty complex, but with a little trick or two, you can solve these nicely. The key is to look at the denominators and find a common denominator between all of the terms. In this case, you'll see that 6x squared would be a good common denominator. Instead of finding the common denominator, what we're going to do is we're going to multiply each term by that value, and you'll see the wisdom of this shortly. If we multiply each of these by 6x squared, in the first case these would divide out cleanly, leaving us with a 1. Here, 6x divided by 2 is 3, and x squared divided by x is 3x. So 3x times 1 just leaves us with 3x. And then finally, all things cancel here, leaving us with a 7. This is a much simpler equation to solve. And so this is a much preferred technique to use. So we'd move the 7 over to the other side, and that would give us negative 6 equals 3x, and x equals negative 2. So quickly, just to recap, the idea is to find that value that every one of the denominators will divide cleanly into, and in some cases completely canceling, in other cases leaving us a little bit of a remainder to multiply times the current term. But the nice thing is that it creates this very nice solvable problem. Let's look at another case of this. This one has some more demanding needs to it. First of all, the one thing you should notice is that you can factor this denominator. And in doing so, you can now, I think, a little easier see what we would multiply everything by. So in this case, we're going to multiply all the terms by x plus 1 and x minus 1. So I'm going to do that with each of the terms. And because of space, I'm just writing it this way. Now, these cancel, leaving me with 4x plus 1 times x minus 1. Here, everything cancels, leaving us just strictly with 12. That's nice. And then here we get 3 times both of these values. Now, both of these values, actually, I'm going to just simplify it, come out to be this value here. Now it looks like things are getting kind of more complex than simple, but you'll see in a minute it simplifies up. So 4x squared, and then minus 4x plus 1x minus 1 equals 12, 3x squared minus 3. Now we're going to put all of this on one side. So we bring over our 3x squareds. We get negative 3x here, and I believe we get negative 10 when everything gets placed on one side. Now this provides an opportunity to factor two numbers that multiply to negative 10 but add to negative 3 or negative 5 and positive 2. And there are our two answers, x equals 5 and x equals negative 2. So there are actually two solutions to this particular problem. One thing that you always have to check for is to see if these values run into any conflict back in the original. So you couldn't have a negative 1 for an answer, and you couldn't have a positive 1 for an answer either, but those are not the answers that you got, so these are both valid and good solutions. So sometimes it simplifies out to give you a quadratic equation, and then you would just factor it or solve it like normal. Let me show you one more example, and then we'll finish this up. This is probably the easiest of the examples. The key to this one is just simply cross multiplication. Because this is just a proportion between two values, we're going to cross multiply. We would get x squared minus x. We would get 2 times x minus 1. That still gives us, as we distribute that out, and then again group all things on the same side. So we got a quadratic, we would be looking for two numbers that multiply to positive 2 but add to negative 3, and I think these would be our two answers. And so we'd get x equals 2 and x equals 1. And guess what? If we check this guy right here, I think we realize that that is a no-go for an answer, because if you put in 1, you would get a divisible by 0, which is undefined. So in this case, actually, there's only one answer provided, and that would be the x equals 2 situation. Hope these examples help you out with this worksheet.